Welcome to a new deep dive. Today we're jumping into some really big topics. Big data, AI, 3D printing, and 3D visualization.
Yeah, they're all connected in fascinating ways.
Exactly. Think of this as your quick guide to understanding these key technologies. We've sifted through a lot of material summaries, exercises, real
The
examples,
mission being.
to pull out the most interesting, maybe surprising bits for you. We want to make these complex ideas, easy to grasp, whatever your background, hopefully spark a few aha moments.
Definitely. Not getting lost in the super technical details, but really understanding the main ideas and how they're changing things. Connecting the dots.
Okay, let's start with that first cluster. Big data, AI, and data science. You hear these terms everywhere.
We do. And they're really intertwined. Big data is like the bedrock. It's this massive flood of information being created all the time.
How massive are we talking?
Well, think about volume. Billions of people online, countless Google searches, just the sheer size of the web. Then there's variety.
So not just numbers.
Right. It's tweets, videos on YouTube, map data, all sorts of formats. And velocity, the speed it all comes at us, millions of emails a second, crazy sales figures updating instantly.
Wow. Okay, volume, variety, velocity.
Yeah.
What else?
Veracity. Basically, how trustworthy is the data? Like filtering out spam emails, that's a veracity challenge.
Right, sorting the signal from the noise. Where does it all actually come from?
A huge source now is the Internet of Things, the IoT. Everyday objects, your smartwatch, industrial sensors, smart thermostats. They're all collecting and sharing data.
Got it. So that's the data part. How does AI, artificial intelligence, fit in?
AI is essentially about building machines that can learn from experience and make decisions, a bit like humans do, often using what they call heuristic programs.
Heuristics, like rules of thumb.
Sort of, like figuring out the quickest route home based on past traffic, not calculating every single possibility. Machines can use these kinds of shortcuts, too.
So they're not just following rigid instructions, they're learning. Which brings us to machine learning.
Exactly. Machine learning is how they learn. You feed machines sample data, they look for patterns, build a model from those patterns, and then use that model to make predictions.
Okay.
There's actually a cool tool, Google's Teachable Machine, where you can try this yourself. Train a simple AI to recognize images or sounds. It gives you a real feel for it.
That sounds interesting. Are there different approaches to this learning?
Yeah, the materials point out two main types: supervised and unsupervised learning.
Okay, what's the difference?
With supervised learning, you train the machine with data that's already labeled, so it knows what it's looking for.
Yeah.
Think of flashcards with answers.
Right.
Unsupervised learning is different. You give it unlabeled data, and the machine has to find patterns or structures on its own. Group things together, maybe. It's more exploratory.
So one needs labels, the other finds its own patterns.
Mhm.
Any other big distinctions, like how they work?
Well, supervised learning often uses more straightforward algorithms and gets better with more labeled data. It's often quicker for making predictions based on known categories.
And unsupervised.
Unsupervised can tackle more complex stuff, sometimes using things like neural networks, but it usually needs more data and takes longer to train because it's discovering the structure itself.
And then there's deep learning. That seems to be behind some really big breakthroughs lately.
That's right. Deep learning is like machine learning on steroids. It uses much more computing power and more complex structures, deep neural networks, to find really subtle patterns in huge data sets.
Which leads to things like,
Self-driving cars, for instance. They need to process tons of sensor data constantly. And AlphaGo, the AI that mastered the game Go, that was a huge deep learning achievement.
incredible. The materials also talk about pattern recognition being key for AI. Why is that?
Because finding patterns, similarities, relationships, recurring things in data is fundamental to how AI solves problems. Think about those CAPTCHA tests.
Oh yeah, the click all the traffic lights ones.
Exactly, or figuring out the next shape in a sequence. Humans do that sort of thing intuitively. AI learns it through machine learning algorithms, finding those patterns to make a decision or prediction.
So when AI looks at a picture, how does it see it?
Well, digital images are made of pixels, tiny dots. AI gets trained on loads of images, analyzing the pixel patterns. It learns to spot features, edges, shapes, textures by seeing which pixels often appear together.
Oh, okay.
Eventually, it recognizes whole objects when it sees those familiar patterns. That's image recognition, in a nutshell, used for everything from identifying cats to checking signatures.
Makes sense. And what about reverse image search? I think I've used that.
Yeah, it's super useful. You upload a picture and it searches for similar images online. Great if you see something and want to know what it is or where to find it.
Right. And doodling recognition, like autodraw.
That's a fun one. You start sketching, and the AI tries to guess what you're drawing, offering polished versions.
How does it know?
It's trained on millions of doodles from things like Google's Quick Draw game. Every time someone plays, they're basically helping teach the AI.
Clever. Facial recognition is mentioned too, obviously a big one now.
It builds on image recognition, but focuses specifically on facial features, distance between eyes, jaw shape, that kind of thing. That's how it identifies or verifies people. You see it in photo tagging, face filters.
And it works on video too, not just stills.
Definitely. That's computer vision. Video is just a sequence of images, right? So computer vision analyzes those frames over time.
To do what?
Things like classifying video content, tracking objects as they move, even predicting actions. It's absolutely vital for self-driving cars. They need to constantly analyze video to see obstacles, read signs, judge distances.
Still feels a bit sci-fi, but getting closer.
Okay, what about interacting with devices using our voice?
That's speech recognition. Everyone's voice has a unique pitch and volume, creating sound waves. Speech recognition digitizes these waves, and algorithms analyze them, looking for patterns that match known words. This ties into natural language processing, or NLP, which helps digital assistants actually understand what we're saying.
Like asking my phone, what's this song? Exactly. The speech recognition gets your question, and then music recognition kicks in. Google Assistant, for example, analyzes the tune, matches it in its database, and tells you the song.
Cool. Any other applications?
Yeah, really important ones too, like alarm detectors for people with hearing impairments. It recognizes critical sounds.
That's great. Another area AI is huge in is spam filtering, right? We get so much junk.
Tell me about it. AI blocks millions, maybe billions of spam messages daily. And it's not just text anymore. It analyzes images, hidden content.
And it learns.
Yeah, partly from us. When you mark something as spam, you're feeding data back to the AI, helping it get smarter. Even those CAPTCHAs we talked about.
The squiggly letters.
Right. By solving them, we're actually helping train AI for reading text, OCR, and recognizing images without even realizing it.
Wow. So AI and data science are cropping up everywhere. The sources list tons of applications.
They really do. Communication machine translation, autocorrect, education personalized learning, smart cities and transport planning routes, managing traffic, marketing, health wearables, security with facial recognition, even professional expert systems. It's broad.
It feels like IoT, big data, AI, data science.
Yeah.
They're all parts of one big system.
That's a great way to put it. IoT collects the data, big data systems store it, AI and data science analyze it, mining for insights, which then allows for predictions, better decisions, automation.
Automation, which
Yep.
also means changes to jobs, right?
Yes, that's a really important point. The materials raise workforce transition is a big consequence we need to think about.
And that brings us to the ethics of it all. It's not just benefits.
Not at all. There are significant risks. Privacy threats, potential for discriminatory outcomes if the data or algorithms are biased, liability issues like who's responsible if a self-driving car crashes, even the potential for AI as a weapon.
Serious stuff.
Absolutely. It highlights the need for really careful ethical development. Our checkpoint section mentions advantages like better customer service, but also the disadvantages, privacy risks, high costs. And it suggests ways to protect your data reading terms, disabling cookies.
Any specific examples mentioned?
Yeah, things like automated news writing, Google Maps predicting crowds or translating signs, how Maps uses anonymized traffic data to suggest routes, and even helps cities manage traffic signals in real time. All data-driven AI applications.
Okay, let's pivot a bit. Let's talk about something you can actually, well, touch 3D printing.
Right. Moving from the digital to the physical.
It's not just science fiction anymore, is it?
Definitely not. Unlike your regular printer putting ink on paper, 3D printing builds actual three-dimensional objects. It does it by adding material layer by tiny layer.
What kind of materials?
All sorts. Plastics are common, but also metals, ceramics, even food ingredients. It's basically additive manufacturing building up instead of cutting away.
So how does it work, step by step?
It starts with a digital 3D model, usually made with CAD computer-aided design software. Then special software slices that model into lots of thin horizontal layers. And it generates the instructions, the code, telling the printer nozzle exactly where to move and deposit material for each layer. Then the printer just follows those instructions, building it up. Fused deposition modeling, or FDM, where it melts and extrudes plastic filament, is a very common method.
Like a precise robot building things up. It's making those initial 3D models hard.
It's getting much easier. There are free, user-friendly design tools now. You can even use scanning apps on your phone to capture real objects, and websites let you share and download designs.
Sort of download, scan, build.
Exactly. The materials mention tools like Tinkercad, SketchUp, and sharing sites like Thingiverse. You could print everyday gadgets, replacement parts.
The possibilities seem huge.
Yeah.
What are some real-world examples?
Oh, tons. Education uses it for prototypes, anatomical models. Food industry is experimenting with designs, even personalized nutrition. Fashion uses it for things like sneaker soles or complex dress structures.
Wow.
Space agencies print tools on demand. Healthcare is huge. Custom prosthetics, dental aligners, surgical guides, maybe even organs one day. Architects build models. Construction is even printing houses. And toys, custom designs, spare parts.
It's incredible. What are the main upsides, the benefits?
The big ones are time saving. It's often faster for prototypes or small batches. Lower cost, especially for custom items, as you don't need expensive molds. Tailor-made, easily customized products. And sustainability, potentially less waste, using recycled materials, local production, reducing shipping.
That sustainability angle is interesting.
Yeah.
But there must be downsides too. Challenges.
For sure. Intellectual property is a big one. It's easier to copy designs by scanning or share copyrighted files illegally. Community safety is another, the concern about printable firearms being easily accessible and potentially undetectable. And it's shaking up industry more competition, maybe shifting manufacturing away from large factories.
That printable gun issue is scary. And IP sounds like a legal minefield. The checkpoint section mentions some of this, right?
Yeah, it talks about the advantages like complex designs and cost savings for small runs, but also the copyright problems. And it mentions why governments might support 3D printers and schools, skills for the future, bridging the digital divide.
Makes sense. Balancing innovation with the risks. Okay, final major area. 3D visualization. Getting beyond flat screens.
Right, creating that sense of depth and realism. It's more than just the old red and blue glasses.
What are the main ways we do that now?
Well, there are still 3D glasses, but also autostereoscopic displays, 3D without glasses. Then there's augmented reality, AR, virtual reality, VR, and even holograms.
Let's start with VR. Virtual reality feels like it's really taken off.
VR aims to create a completely simulated environment. You put on a headset, and it immerses you, makes you feel like you're in that virtual world.
How are these worlds made?
They can be totally computer-generated from imagination, using 3D modeling. Or they can replicate real places using 360-degree cameras. The headsets themselves range from simple ones using your phone to powerful standalone units. And controllers vary too, from basic remotes to full motion tracking.
Very immersive. The materials mention using VR to visit the Song Dynasty.
Yeah. Based on that famous scroll painting along the river during the Qingming Festival, it shows how VR can transport you for education or just experience. There are links to try flying, concerts, skiing, dinosaur worlds, all sorts of VR stuff.
So it's not just for gaming then?
Oh, far from it. Media is exploring VR cinema. Gaming is big, of course, but also military training simulations, surgical practice in healthcare, theme park rides, visualizing the solar system in education, watching sports events immersively, even Google Street View in VR.
Wide range. What are the ethics? I saw something about reuniting with deceased loved ones.
That's a complex one. VR could potentially offer closure, but there are big questions about exploiting memories, consent, the risk of people getting lost in it. Definitely something to consider.
Yeah. Okay, so what about augmented reality, AR? How's that different?
AR doesn't replace your world, it adds to it. It overlays digital information, images, text, graphics onto your view of the real world, usually through a phone screen or smart glasses.
Like seeing furniture in your room before you buy it.
Exactly like that. It enhances reality instead of replacing it. These overlays can be designed or based on 3D scans of real objects. Remember that bus shelter ad example?
Vaguely. What was it?
It made it look like unexpected things, like a tiger or aliens were appearing right there on the street, seen through the window of the bus shelter display. Very AR.
Ah, right. In the Google Translate example.
Yeah, activity 1.5. Point your phone camera at a menu in another language, and Google Translate overlays the translation right onto the image using AR and OCR. Super practical.
That is useful. Where else is AR popping up?
Education, again, 3D anatomy models, military heads-up displays for pilots, architecture for visualizing designs on site, entertainment, think face filters, gaming, AR tower defense, healthcare dentists using AR overlays, surgeons getting info on smart glasses, car manuals with AR labels. Travel AR navigation and maps showing directions overlaid on the street view.
It's becoming pretty integrated. And then holograms, Star Wars time.
That's the classic image, isn't it? Unlike VR needing screens or glasses, holograms appear as 3D images floating in space, visible to the naked eye. The materials mention Star Wars experiences and that Michael Jackson performance.
Can you make one at home?
Sort of. Activity 1.6 shows a simple DIY projector using a plastic pyramid and special videos on your phone. A fun little project.
Might have to try that. Okay, looking at all this 3D visualization tech, VR, AR, holograms, what are the overall pros and cons?
Benefits include things like realistic virtual training, more flexibility for collaboration or learning from anywhere, sometimes lower costs than real-world setup.
And the limitation.
The digital divide is a big one. Not everyone has access. Privacy is a concern, especially with AR collecting data about your surroundings.
Right.
You can become less aware of your actual environment, and you often need some technical know-how.
Right. Our checkpoint section mentioned AR, VR being good for education, virtual field trips, better engagement.
Yeah.
But also how AR furniture apps need web and algorithm skills, and relying only on AR for online shopping could leave some people out.
Exactly. It's all about finding that balance, using the amazing potential while being aware of the challenges, ensuring access, and developing responsibly.
So wrapping this all up, quite a journey today. We've gone from the sheer scale of big data and how AI, especially machine learning and pattern recognition, makes sense of it all in images, speech, even spam.
Then into the physical world with 3D printing, that whole process from digital design to actual object and its impact everywhere, from healthcare to toys.
And finally, diving into 3D visualization, immersive VR replacing our world, AR augmenting it, even a touch of holograms. Plus, considering the benefits and the hurdles for all these technologies.
And the key takeaway, really, is how interconnected all this is. IoT feeding data to AI, driving automation, visualization, changing how we interact. It's all converging and reshaping things fast.
Definitely. So as we finish this deep dive, here's something for you, the listener, to chew on. With all this rapid change in AI, 3D printing, VR, AR, what future developments or shifts do you find most exciting? Or maybe what worries you the most? How do you see this technology weaving itself even deeper into our lives?
Yeah, great questions. We hope this gave you a good overview. There's always more detail in the resources, and maybe trying out some of those activities like the teachable machine or the DIY hologram is a good way to explore further yourself.